So if we define the problem of sorting by saying that after sorting an array, the smallest element must be in the first position, the second smallest element must be in the second position, and so on, then the brute force algorithm that achieves that would be selection sort, which just goes through, selects the smallest thing, puts it in the first position, and then second smallest thing, and so on. So if we start from a different definition, we end up with a different brute force algorithm. So the question is asking us to consider the definition that an array is sorted if each element is no greater than its successor. So in other words, we've got some array A. Let's say it's indexed 1 to n. And what this definition is saying is that for any pair of adjacent elements, I and I plus 1, that element I must be less than or equal to element I plus 1. Okay, so the brute force approach to this would presumably be to say, I'm going to repeatedly find pairs of adjacent elements, and if they're out of order, swap them. And I just keep doing that until I can't find such a pair, and then I must be done. So then the question is just, how should I find pairs like this? So one reasonable idea seems to be to just scan through the array. So I make a pass starting at element 1 and comparing it to element 2, and I go all the way through the array up to element n minus 1, and for each pair, if they're out of order, I swap them. Okay, so my inner loop is basically going to say if for any pair the first element is larger than the second one, then I should swap them. Okay, so I'm going to perform, say, one of these loops. So I make one pass through the array. And what we can say after that is that at some point we will have encountered the largest element in the array, and after that we will continuously do the swap until the largest element ends up in the final position. So after one pass, the largest element is in the final position. And to do one of these passes is going to cost me big theta n time. And it should be clear that I'm going to have to do n passes in order to get the remaining maximum into its position. So the overall complexity is big theta n squared. Okay, there's a couple of optimizations I can make, and that's what this second part of the question is asking about. The first is to realize that if at any point I don't make any swaps, then I can quit, because it must be the case that everything's in order and I can stop. However, there's something else I can do as well, which should be obvious from what I've already described. So when I'm making this linear scan through the array, if I've already made, say, k passes, then I know that the top k elements are already in the right position. So after the first pass, the maximum element was in the last position. So that means now the last pair I need to compare is n minus 1 and n minus 2. So I don't need to go all the way to the end each time, and the amount of work that I'm doing is reducing each time. Okay, so the passes get shorter. However, this is still an n squared algorithm, and in fact with those two optimizations this is exactly bubble sort. So it's not a particularly good choice of algorithm, but it is the sorting algorithm that arises from this definition of sorting and then applying brute force.